normally the mean value of the set of the data is sum of all divided by how many numbers are there. When we have a sampling, we use the mean as a notation X bar. So X bar stands for the mean of the sample, mean of the samples. And then mu is the mean of the whole population. Okay. Now, let us pass now these things. Now we have something which is called expected value. When we have a random variable, which is, for example, when we throw a die or when we flip a coin. So normally, theoretically, it is 1/2 for the coin to be head or tail, or theoretically to see the number 1 or number 2 or number 3 up to number 6 is 1/6. But in practice, so you are taking a coin and flipping. So it is head, it is head, it is head, it is head, later on tail, tail, head, tail, blah, blah. So you are recording all the cases, all the experiment, and then you are creating a table. And based on this table, we can make some predictions, or based on this table, we can say the mean value of this table. So this help us for the upcoming test results. I mean, I can say that I tried this experiment or I run this experiment 100 times and I have seen this amount, or I have seen the other one this amount. So most probably if I try it, so it could be something like that. Now, what is the expected value? So expected value, we are using as a notation EX, or we are saying this is the mu, and as a formula, this is equal to x1 times probability of x1 plus x2 times probability x2 plus blah, 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 xn times probability of xn. So if I want to write this simply, shortly, this is equal to xi times pxi, where I is from 1 to n. And then we will see examples. Now, find the mean of the number of the spots that appear when a die is tossed. So it says that normally to see number 1, 1/6, to see number 2, 1/6, to see number 1, 1/6. So what will the mean value of this? The formula is 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 and so on. And finally, we get 3.5. We get 3.5. When a die is tossed many times, the theoretical mean will be 3.5. What does it mean? I mean, you are tossing, you see number 1. You are tossing, you see number 3. You toss number 5. You see number 6. You toss it number 2. So, for example, you repeat this 100 times, 100 times. So what will the expected mean? It means that this number plus this number plus this number plus this number plus blah, 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 100 trial. So divided by 100, which is n is 100. So this is called the mean of this 100 tryings results. But now when I use, after creating the table, I can say that expected value or the mu, it's 3.5. So the things you try it 100 times, another 100 times, another 100 times, most probably the things will be around this point, around 3.5. Now, in a family with 2 children, find the mean of the number of children who will be girls. So if you have a family, so you have a boy or a girl, let's say, it says that there are 2 kids. That means the possibilities is, if I call the axis to be a girl, no girl means both of them boys. 1 girl means 1 boy, 1 girl, and 2 means here both of them are girls. So what is the probability? So it is 1/4. Why? Being boy and boy at the same time, I mean the first kid and kid is boy, it is out of 4, since totally there are 4 cases. How are they? B, 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 G, G, B, and G, G. When we think these 4 cases, being in the first and in the second B, it's 1, and out of 4, so its probability is 1 over 4.
Mr.
But to have a 1 boy, 1 girl, even be careful, it's not only BG, it could be even GB. Am I right? 1 boy, 1 girl, or 1 girl, 1 boy. I mean, the order it's important. First kid is boy, second kid is girl, or first kid is girl, second is. So this will be 2 out of 4, which is 1 over 2. And then being all girls means the first one is girl, the second one is girl. That means there is only one case, is first and second is girl, so 1 out of 4. And what is the expected value then? 0 times this plus this time this plus this time this. So result is 1. Yes, Abdullah, question?
Mister, you can just do the probability of a girl is 1 over 2, and then probability of another girl is 1 over 2. So you times 1 over 2 by 1 over 2, you get 1 over 4.
You are talking about which part? One more time.
So, for example, BB. So
BB. Okay.
the probability of 1B is half. So if half times half, it gives you 1 over 4.
That's the other logic. Yes, that's correct. You can use this logic also. I mean, the first and the second place. First kid and the second kid. You can say that first one is to be a boy, 1 over 2. The second one to be a boy, 1 over 2. So 1 over 2 times 1 over 2, 1 over 4. That's okay. Also, even it could be, I mean, all the alternatives from the sample space, BB, BG, GB, and GG. We don't have another case. And then this is 1 out of 4, so 1 over 4. They are both acceptable. That's correct. There is no problem.
Okay.
So the question then, if a family with 2 children find the mean number of children who will be girls, the answer is 1. Okay, I mean, what does it mean? As a mean value, one of the kids could be a girl. And similarly, we have questions, so no need to explain since we did it. I am passing, okay? And the variance, normally the variance is x minus mu to the power of 2 over n. What does it mean? If you think that this is the mean value, and these are your data values, okay, what is the variance? Variance is this mean value and this actual point, the difference you are taking. After taking the difference, you are taking power 2 and adding this to the other one. So the second point and the mean, take the difference here and take their square and so on. When you finish all the points, you are taking this sum, again, difference to the power of 2, divided by how many members you have used, then this is called the variance. When you take the square root of the variance, it is being standard deviation. So what about here? This is for normal numbers. What about here for the probability, for the random variable? The rule is this, x minus mu to the power of 2 times px. What does it mean? x1 minus mu times p1. By the way, there is power 2 plus x2 minus mu to the power of 2 times p2 plus and so on xn minus mu to the power of 2 times pn. So this sum, it's equal to variance. And what about the standard deviation? Just square root of this thing. And then it will be the formula x squared times px minus mu squared. It's another formula. So the another formula, this is also variance. 1 minute, variance square, which is standard deviation. So variance is, by the way, x squared times px as a table when we do this. And then finally, mu squared. Let's see one example. So I can paste this. Yeah, here how to find the variance and standard deviation. First of all, I can find the mu 3 times 2 over 5 plus 4 times 1 over 5 plus 5 times 2 over 5. So this number will be mu. If we calculate this, 3 to 6 over, or let's say 6 plus 4 plus 10 divided by 5. So it will be 20 over 5, which is 4. Now mu, which is expected value, is 4. And what will be variance? So the variance will be this. So 3 squared times 2 over 5. So 3 squared times 2 over 5 plus 4 squared times 1 over 5 plus 5 squared times 2 over 5. When you get this total minus mu squared. Why? The formula says here that one. So the variable square times its probability when you finished all minus expected value squared. This is called variance. And what will be standard deviation? Standard deviation will be square root of the variance. So when we calculate all, for example, standard deviation comes out this number. I'm not dealing, it's not difficult, and we already did before. So I am passing. So mu is called expected value also. Okay, and we talk about this winning tickets issue. I already explained in the other revision, so I'm not going to talk one more time. But if you need, we can talk. It's fine. Quickly, I can talk it. 1,000 tickets are sold at $1 each for a color television, which is valued 350. So you are buying, let's say you are buying a ticket. So you pay $1. If you win, or when you win the TV, let's say, you got the TV, which is $350, but your actual winning is 350 minus 1, which is $349. Why? Since you already paid to buy a ticket. So since you are the lucky guy, so they do give your money back? No, just they give the television to you. So this is 350. You already pay 1, so 350 minus 1 will be 349. So if we call the variable is to gain, it means to win, okay, or gain X, let's say. So to win will be 349. Why? If you win the television, you got 349, since you have to deduct the money you pay for the ticket, so which is 349. So what is the probability of to get this TV? Since there are 1,000 people here, so there will be only one television. For that reason, the probability to get the right ticket 1 over 1,000. And then if you are not winning, so there are 1,000 people, just one of them will win the TV. It means that 999 lose the TV. So they will not win the TV. So losing is since they pay the ticket in order to attend this lottery, let's say, so they will give $1. Giving means negative we are putting. So what is the probability of losing? Since there will be 999 loser, just one winner. So 999 divided by 1,000. Now what will be expected value? The formula is saying this one times this one plus this one times this one. So let's sit down. So 349 times 1 over 1,000 plus negative 1 times 999 over 1,000. So negative 0.65. What does it mean? For each ticket, let's say the company is selling, okay, they won $0.65. So each guy is spending $1, but the company is getting $0.65 from the each ticket. So expected value is negative 0.65, means everyone is losing $0.65. It means, okay, and if there will be 2 tickets, what will be? So you are buying 2 tickets. And so if you are buying 2 tickets and each of them $1, that means the probability of to win this prize 2 over 1,000. And then the problem, if you remember, we studied this in the class, you are putting the same ticket to the box. So sample space is not changing. Still, you have 1,000 alternative out of, I mean, 2 alternative out of 1,000 in order to get this price, get this price, get this price, and get this price. Here, you know, when you are losing this, it means that you have already spent $2 and you do not have anything in your pocket, in your hand. So you have lose. These are the to win this prize. So since 2 times you are getting a ticket to get the chance to over 1,000. Yes, question, Abdullah?
No, Mr. Khalas, you just answered it.
Okay, so normally this is $100, but you pay $2. For that reason, 98 is your actual winning. So you pay $2. This is actually $50 you are getting, but since you pay $2, your profit will be 48. And then what is the expected value? This time this, this time this, this time this, this time this, minus this time this. So it is negative 1.63. What does it mean? It means that for each ticket, the company is getting this amount of money, 1.63. Okay, so if there are 1,000 people and each of them, if they buy 2 tickets, they will get more money, but it doesn't say each of them they get 2 tickets, right? Or it says after each try running, the winning ticket is to return the pool. When it's if you purchase 2 tickets, says it means that 1,000 times 2,000. So 2,000 times 1.63, it will be in the company box, let's say, the company will get. Okay, this is similar to this question. I am passing. We may have a look here at some questions, but imagine how can you find, for example, here, how can you find here variance? How can you find standard deviation? Just one of them solve it. If we got the right answer, that means it is over. And something I should add also, to call this the probability, always this sum must be 1. You shouldn't forget this. Yeah. This must be 1, okay? If it's not 1, that means there are missing parts. There is a gap here. We have to fill it. Okay, let's go down. Now, how to use the calculator, it teaches us here. So now, important thing, binomial experiment. What is the binomial experiment? Binomial experiment is a probability experiment that satisfies the following 4 requirements. There must be a fixed number of trials. What does it mean? I am throwing 100 times a die, 250 times I am flipping a coin. So there must be a fixed number. You have to know in the problem how many times you are repeating one experiment. Or for example, you are receiving a phone call daily basis. Let's say in a one day, you get approximately 150 phone calls. So 150 phone calls, it's being our number n. Each trial can have only 2 outcomes or outcomes that can be reduced to the 2 outcomes. These outcomes can be considered as either success or failure. What does it mean? Flip a coin to see head or not to see head, to see tail or not to see tail. Flip a die to see number 1 or not to see number 1, to see number 6 or not to see number 6. For the exam results, AP Statistics, AP Calculus exam, AP Physics exam, to pass or not to pass. Okay, I mean, you can say that, teacher, if I got 0 or 1, I fail. If I got 2, 3, 4, 5, I pass. So easily, what can I say? If you got 3, there are 2 cases. You pass or you fail. Of course, you pass. If you got 4, you pass or you fail. I mean, there are 2 possibilities. Okay, the outcomes of each trial must be independent of another. This is very important. So let's say there are 100 tickets. There are 100 tickets. So when you draw one of the tickets. When you pick one of the tickets, so left 99 tickets. And if you draw another thing, left 98 tickets. So in this scenario, all the probabilities are changing. 100, so 99 in the denominator, 98. So is this a binomial? No, this is not a binomial. Since you will not have equally likely to be chosen to get, let's say, the lucky number, or to see the number 6 on a die, or to see the hat. Why? If you are not putting back, if you are not replacing it, it means that your sample space is changing. When your sample space changes, so the probability is overall change. So this is not called binomial. So we cannot call this as binomial. To be a binomial, you look at, you take a note, and you put it back. Yeah, still 100, still 100. That means this is binomial. So the probability of success must remain the same for each try. And for the binomial, we call two letters, P and Q. P stands for success, and Q for the failure. And Q could be expressed by 1 minus P, or P could be expressed by 1 minus QY. To be success, to get success or to get the failure. So the total, it is all the cases. We have two cases, to be successful or not. So what is the sum of the probabilities? Always it is 1. So P plus Q is always 1. Okay, let's go down. Now, this is the normal formula, binomial probability. What does it mean? N factorial, n minus x times x factorial. It is normally combination of nx. It means this part is called combination of nx. And then P is probability of success. So Q is 1 minus P, which is probability of failure. And here in the formula, if we get, this is x, so how many times I want to be successful? So this will be n minus x. Always the sum, this power and this power, which is x plus n minus x, it is always n. Now let's see example. A coin is tossed 3 times, so n is equal to 3. Find the probability of getting exactly 2 heads, so x is equal to 2. So what I want, n x to the power of, p to the power of x times q to the power of n minus x. That's the formula. So what is the to be successful? What is the success for the coin? What can I say? What is the success for the coin? To see the head. What is that? It is, what can I say? What is the probability of to see the head?
Half.
Isn't it 1 over 2? Half, yeah. So the probability to be successful, which means to see the head, 1 over 2. And what about not to see the head? It is half. 1 minus 1 over 2. It's also half. For the die problem, 1 minus, tell me, not 1 minus, let's say, to see number 6, for example, 1 over 6. So not to see 1 minus 1 over 6, which is 5 over 6.
Yeah.
Okay, and then the question is, you want to get exactly 2 heads, which means this case, or this case, or this case. You don't want this, you don't want this, you don't want this, you don't want this, you don't want this. So directly by using these alternatives, the answer is 1, 2, 3. Out of how many? 1, 2, 3, 4, 5, 6, 7, 8. That's the answer. But what will be if there are, let's say, 100 tossing? We 100 times toss this, not 3 times. So H, all the others tail, or H, tail, H, tail. It's very huge, very big number. I cannot write this. So I cannot think this in my mind. It's so difficult. For that reason, I can use the formula. What is the formula? N how many times you are repeating this action, how many times you are making an experiment. Tossing the coin means it's one experiment. 3 times tossing means 3 experiments. So 3. So in these experiments, how many times you want to see the success? So your success is to see the head. So I want to see it how many times? 2 times. So combination of 3, 2, combination of 3, 2 times the success is 1/2 to the power of these 2 times 1 minus 1/2, which is still 1/2, and 3 minus 2, which is 1. So this total, don't forget, always will be number of experiments. And then when we use calculation, I mean, when we do the calculations, even we can do by ourselves, 3 factorial, 3 minus 2 factorial times 2 factorial, and then this result will comes out. Or you can use, if you have the scientific calculator or even the online website, it is called Binomial PDF. Here you are writing number of trials, which is 3, and here you are writing the success rate, which is in our question 1/2, and then how many times you want to see this success, 2 times you want to see. When you enter, result comes out. So let me check it. Do we have the online PDF or not? I don't know. Have we checked it before? Online, what we said, Binomial PDF. Binomial PDF. Let's check it. So in the exam time, you can use it. Yeah, the first link. I'm just looking. Probability of success on a single trial. So 1/2. Number of trials in my question, 3. So number of success, how many times I want to see 2. Binomial probability, you want to say exactly 2, right? So calculate what it says. I didn't fill. This is the reason. The probability of success must be between 0 and 1. Yeah, between 0 and 1 isn't 1. 1/2 is between 0 and 1. Okay, let's try 0.5 then. Maybe it doesn't work. So result comes out. You see now 0.375. So exactly to 3.75. Is it clear?
Yes.
So, and this is very good application right now. Why? It says that probability of, let's say, less than 2, which is 0.875. Probability of greater than 2, which is 0.125. Equal 3, I mean 3 or more than 2 or more than 2, which is 0.5. Also, you can find by using this calculator lots of things. Otherwise, what can you do? You can use, by the way, this website is a very good website. You can use this. You see all the tests are here. So if you use the scientific calculator, let me show you quickly. Open, yeah. You can download and install to your computer. Approximately 3 months is free. For 3 months or 4 months, maybe you can use this free of charge. And then you have to buy it if you wish. But no need, use one email, use another email, and get it free. Now, second was and Binomial PDF. So let's go down. Yeah, it is here, Binomial PDF, enter. So number of trials, 3. So 1/2. And then how many times success I need 2. When I say enter, result comes out 0.375, which is 0.375, which is in our case 0.375. Okay, we did it. Good. So another question. It's a good question. A survey found that 1 out of 5 Americans. So I stop here. So it's a proportion. It's a success. 1 out of 5. That's it. He or she says that visit a doctor in a given amount. If 10 people, I stop. So n is equal to 10. 10 people are selected randomly. Find the probability exactly 3. So x is 3. Finished. So you can say that 10 by 3, So 1 over 5 to the power of 3 times 1 minus 1 over 5. So this is success, this is failure to the power of, if this is 3, this will be 10 minus 3. So this result will be answer of your question. Or by using the online application, let us use. So we have the success rate is 1 over 5. What is 1 over 5? 1 over 5 is 0.20, right? 0.20. And then number of trials, 10 times. How many successes we want to see? 3 times. So when I say calculate, result comes out, it was 3 times, right? Yeah. Result comes out 0.201 here, 0.201. Yeah, look at 0.201, it's here. That's it, finished. Anything to ask me? No, good. Now we can pass this. It says you can use the table, we can pass this. Similar things. Now, for the mean variance, we can say that mean value is equal to n times p. P is the success rate, okay, success rate. And n means how many times you are repeating the action, how many times you do the experiment, even you can say. And the variance is equal to npq, and then standard deviation is equal to npq in square root. What is that? The mean variance standard deviation of variable that has the binomial distribution can be found by using the formula. So before we use, if you remember, mu is equal to sigma x times px, we said, and variance is equal to sigma x squared times px minus mu squared, we said. So also even you can use this formula. But when you can this formula, of course, you have one problem and one solution. Let's have a look here. A coin is tossed 4 times. So n is here 4. And find mean. So this is question mark. Variance. So this is question mark. I already asked this in the quiz, as I remember, right? That's it. The deviation of the number of heads that will be obtained. So what is the number of head to see the head? To see the head, 1 over 2. So what is the Q? 1 minus 1 over 2, which is not to see head. It means to see the tail, which is 1 over 2. And then n times p, 4 times 1 over 2. It comes 2. Variance, n times p times q, 4, 1 over 2, 1 over 2, 1. And standard deviation, square root of 1, which is 1. That's it. We solved the question. Now, chat box, let me check. Is there anything here? Binom CDF is C means for cumulative. C means for the cumulative. So, for example, imagine, let's say, or in the formula, let me show you here. This is now CDF, for example. Okay, so probability, can I annotate here? Probability, something less than, for example, 3. It means that 0 success plus 1 success, 2 success, for example. That's it. To find this, I can use binom CDF. So what am I going to put here? Mean, not mean, of course, n, comma, the success rate, which is p, we can say, and comma, x. But this x here, be careful, up to here will be calculated, What does it mean? It means that if I put it here 2, I will get the answer of this. I mustn't put it here 3. So this 2 means here includes also 2. I mean this formula, P0 plus P1 plus P2, that's it. Since if this is tilde 2, okay? If tilde 2. Now, if you see the question, we can talk now about that. Now, the same thing, nothing different. It's same what we said. So let me go down. and PQ, same thing. And I think the quiz question was this, the first quiz question. Maybe numbers are different, but same. So now the same thing, we can pass. Okay, for example, try to answer these two things. So nu is n times p. So result will be directly 75 by 0.75 times 100, 75. And then variance is equal to n times p times q. N is now here 100. Now p is given 0.75. If p is 0.75, what will be q? Q will be 1 minus 0.75, which is 25, 0.25. So this result gives us 75 times 0.25, and then calculation you can do. What about standard deviation? So this result, square root, will be standard deviation. For example, construct a probable distribution from this. How can you construct? Yeah, it's a good idea to ask this kind of question. For example, x and probability of x to C0, to C1, to C2, to C3. And then what is the probability of to C0? It is 0.125. What about 1? It is 1 minute, 0.375. To C2, it is same, 0.375. And to C3, it is 0.125. That's it. So the answer of this question is this. You can say children in a family, or let's say number of girls, it says so, number of girls, okay? And then probability of number of girls. Meanwhile, always we have to check this total must be 1. So this will be 0.250. This will be how many? 600, 750. So is this 1, 0, 0, 3? Yeah, this is 1, so it is satisfied. That's it. We construct from the table this one. Okay. Now let's go down. Now, the same thing by using exam. This is optional, not important. I am passing. This is optional, right? We can even talk, but optional, pass it. Now, Poisson distribution, it's an important thing. What is Poisson distribution? So Poisson distribution means, let's read the definition. First of all, when we will use this is important. The probability of X occurrences, I mean, sometimes occurs X times, when or how, in an interval of time. So let's say in the morning, in the afternoon, or all the Mondays, all the Wednesdays, all the Fridays, or once a month, twice a week. So there is a time period, or in the volume, or in the area of the figure. For a variable where the lambda, it's a Greek letter, the mean number of occurrences per unit. So be careful now. What is lambda means? The mean number of occurrences per unit, like a mean. And then formula, Poisson distribution, x semicolon lambda, it is e to the power of negative lambda times lambda to the power of x, and x factorial. One more time, what is x? Number of occurrence. How many times occurred that event you are looking for. And then lambda means here mean number of occurrences per unit. So like the mean, we can say. And then factorial is factorial. And E is meanwhile 2.7183, but of course it's better to use the calculator, since in the calculator there is a button which is called E. Example, if there are 200 typographical errors randomly distributed in a 500-page manuscript. So there is a manuscript, there is a book, let's say, or there is a book, let's say, and this book has 500 pages, and it says that 200 errors exist. So what will be for specifically for one page the error ratio? It is 200 divided by 500, which is 0.4, will be my lambda. Why? Find the mean number of lambda errors. Since there are 200 errors distributed over 500, each pass has an average of this. Let us remember that what is lambda? Lambda is the mean number of occurrence per unit. So in my question, 200 times the error occurs, 200 times the error occur. So what will be unit time, or let's say mean of unit time for this? Since totally there are 500 pages, just for one page, the mean value will be 200 divided by 500, which is 0.4. Now, and then the question says that when you randomly choose a page, so what is the probability that in that page there are exactly 3 errors? There are exactly 3 errors. So I can say that this is Poisson, since I am talking about the unit things, which is now x comma lambda. What is now x here? How many error I want to get? Here 3. And now what is the lambda? 0.4. Just put it in the formula. E is this number, or just use the calculator. Let it is E on your calculator to the power of negative lambda. So negative 0.4 times 0.4 to the power of how many times this thing occurs. We want to see, I mean, as a probability 3 divided by 3 factors. So the answer of the question is there is less than 1% chance that any given page will contain exactly 3 errors. So this is very less, right? So the probability is not high. It means that most of the pages when we look at, there will be less than 3 errors. So guys, this question is a good question for the quiz. Get ready to answer this kind of question in the quiz. You can use a table. There is a Poisson table, but without table also we can solve the question. A sales firm receives on average. So when you read, this is a keyword, on average, it means that this is Poisson. A sales firm receives on average 3 calls per hour. Another keyword, per hour, it says. It's a toll-free number. So I can say that directly lambda is 3. What do you think? On average per hour, 3 calls. Yes, this is the lambda. For any given hour, find the probability that it will receive the following. So at most 3. At most 3. What does it mean at most 3? It means 0, 1, 2, or 3. So how can I find Poisson 0, 3, Poisson 1, 3, Poisson 2, 3, Poisson 3 by 3. That's it. What is the formula? E to the power of negative lambda, lambda to the power of x divided by x factorial. Let's be sure about the formula. E to the power of negative lambda, lambda to x. Yeah, that's the formula. And by using the formula, we will get the result. The second part, at least 3. What does it mean, at least 3? It could be 3, 4, 5, 6, 7. How many? I cannot count how many calls I will receive. For that reason, I can use the, PA plus PA complement is 1. I can say that 1 minus P x is 0, P x is 1, P x is 2. I can use this one. Okay, when I use this, I mean, x is 0 means, let's say Poisson, better to say not in this format, better to say in this format. We are writing firstly lambda. So what is the lambda? Pardon, I couldn't delete. So lambda is in our question, it was 3, right? So 0, 3, 0, 1, 3, and 2, 3, semi-comma. That's it. So this is the x, this is the lambda. X, this is the lambda. So which is, it's here, 0, 3, 1, 3, 2, 3. So result is this one. When I subtract it from 1, I will get exactly what I want. Okay, similarly, I can continue. Another question. If approximately 2% of the people in a room of 200 people are left-handed, find the probability that exactly 5 people are left-handed. So what is the mean? It says that 2% of 200 people. So how can I say 0.02 times 200, which will be 4. This is now my lambda. Well, this is my mean value per unit. Is this clear? Is this clear or not?
Yes, yes.
And then what is x? X is here 5 people, it says. So the answer is Poisson 5, 4. What is that? The answer is e to the power of -4 times 4 to the power of 5 divided by 5 factorial. When we write it, the result comes out for us. Hypergeometric distribution, it's not, did I explain this hypergeometric in the class?
No, miss, you skipped it. You said this is
Yeah,
not
I think I skipped it. No need now. Let us pass. So let us pass. We may even talk about no need now. And for the Poisson, I forget, for the Poisson, we also calculator. So even the online one, I think it was, let's check it, Poisson.
Yeah, mister.
So
The same
here,
website has it.
yeah, here you see, click the Poisson. What is this? Close.
Close that.
Yeah. Poisson random variable, average rate of success. So what is the Poisson random variable and average rate of success? For example, this question, if we solve this question.
Mister, here we can find the at least and
This
more.
question, let's solve. For example, this question. Now 4 is now our mean value. So average rate of success and Poisson random variable. So average rate of success, I think I should say, which is number 4. And then here, how many thing I want to see? 5. So when I put it 5, if I say calculate, result comes out 0.156. So 0.156, that's it. Okay. And when I want to talk this case, for example, this question, let's say at most 3, at most 3. So what was the lambda? 3. Let me write it here. Lambda is 3, and Poisson random variable at most 3, right? They are both 3. Yeah, they are both 3. So when I say calculate, here be careful, at most. So my x less than or equal to 3, I can choose. I can choose this one. What is the result? 0.647. Let's check it. 0.647. You see it? 0.647. Am I clear? The same thing. This
Yes.
one, we will check it. So when we say here probability of x is less than 3, it means that 0 is here, 1 is here, 2 is here, and 3 is here. So if we say more than 3 or at least 3, this is now at least 3. It means that minimum 3. It could be 4, it could be 5, it could be 6, 3, 4, 5, 6. To do this, I can say that 1 minus Poisson of 0 plus 1 plus 2, and then I will get this result, or just use the online calculator.
So can you send the website?
Pardon?
Can you send this website?
Yeah, I can send it. When I Google it, this is the first So let me send it here, Google chat. And also I can send it to the, tell me, Google Classroom. Let's say, instead of calculator, you can use online calculator, which is this. Send it. Let me send also to the boys, to the girls this. This is boys section, so girls section. Send it. I don't want to forget it. Let me do it right now better. So put it here and enter. It is finished. Now, okay, let's go on where we were. Okay. I'm passing this. Now, also for Poisson, for the online calculator, we have CDF, Poisson PDF, and Poisson CDF. It's the thing what I have right now explained. Okay, so now page 300, it's for normal distribution. Before starting normal distribution, just let's give 5 minutes break, okay? Or 6 minutes. At 5 o'clock, we will be here. 5 o'clock. Tamam? So, now normal distribution. What is a normal distribution? When we talk about in our daily life, so the things tend to be a normal if we enlarge the number of sample space. I mean, if we are repeating any event so many times, it's tend to have a normal distribution. So for the non-random variables we are talking. For example, when we look at this figure here, so random sample of 100 women. So imagine there are 100 women. There is one, let's say, the result of the survey is graphed by using the histograms. So we have this distribution. And when we increase, sample size increase and the class with decrease, so we will have this figure. And sample size increase and class with decrease further. The normal distribution for the population. So we will have at the end something like a bell-shaped figure. Okay. Now, for the normal distribution, some characteristic properties, some important things, where the curve peaks, okay, or they hit the peak point, we are calling this point the mean of the distribution. And sometimes instead of mean, we can say median or the mode. And this distribution is called the normal distribution. Here, when we look at that, this distribution is called negative skew distribution. For the negative skew distribution, the most important thing in the SAT they are asking, mean is less than median, and here this is less than mode. So the mean values are on the left of the curve, or the mean values are, when we talk about the peak point, okay, it's being on the left of the peak point. But when we talk about the positively skewed things, so the peak point is here, and the mean values are being on the right side. So if it is positive, the mean on the right side of the peak. If it is negative, the mean is on the left side of where the function or where the distribution hits the peak there. So we can say that mode is less than median and is less than mean, and always median is between them. So to keep in your mind, mean is less than mode, or mode is less than mean, to be a positive or to be a negative. Now, for the normal distribution in calculus, okay, there's a formula. So this is the integration from somewhere to somewhere, this function. We explain this distribution in the calculus, but we are passing this. It's not important for us. In statistics, what are we going to do? What are we going to see? I will explain. Now, when I look at these figures, these are the important things, the shape of the normal distribution. I see that the peak point is here for this curve, and the peak is here for this curve. When I look at here, when I drop this, okay, on the x-axis, so the mean value of the first curve is equal to the mean value of the second curve. But when I look at the tails, for example, here, and for example, here, when I look at the tails, this green tail is longer than the red one. And why? The reason is the standard deviation of the green one is greater than the standard deviation of the red one. So let's say sigma 1, sigma 2. For that reason, they have the common mean, but since the standard deviations are different, so how large is that? How large is that? Your tails are being far away from the mean, far away from the center of the distribution. And look at here, the mu1 and mu2, which means the population means these are different since there is an x value here, there is an x value here, these are different. When I look at now, like a point of inflection calculus lesson, when I look at here, this thing is called 1 sigma. So 1 sigma difference, or 1 sigma distance from the mean to my curve. When I look at here, what I see, this is also 1 sigma. I mean, this length is equal to this length. So what I say, different means, but same standard deviation. So when I look at here, now the tails are, this is now sigma, this is also sigma. So when I check them, different means and different standard deviation. I mean, this length is larger than this length. So the tails are different. Since sigma 1 is greater than sigma 2, this tails is far away when I compare with here the tail. So normal distribution is continuous, symmetric, bell-shaped distribution of a variable. These are the important things. A normal distribution is curve. I mean, the normal distribution curve is bell-shaped. The mean, median, and mode are all equal and are located at the center of the distribution. So we can call that here, this is mean, this is mode, and this is median. So this is at the center. It means that this is 50% and this is 50% of the overall data. A normal distribution curve is a unimodal, so it has only one mode. So where the function picks, it's just one mode. The curve is symmetric about the mean. It's very important, which is equal to saying that its shape is the same on the both sides of vertical line passing through the center. The curve is continuous. There are no gaps and holes. For each value of x, there is corresponding y value. The curve never touches the x-axis. Theoretically, no matter how far in either direction the curve extends, it never meets the x-axis. I mean, here it's getting smaller and smaller, but it's very, very, very close to the x-axis from right and left, but never touch this, okay? It's getting, I mean, always there is a difference between this curve and the x-axis. So this difference could be like that. It's a very small number, but difference is difference. So the total area under the normal distribution curve is equal to 1 or 100%. It's a very important property. We use this to solve the questions. So the area under the part of the normal curve that lies within one standard deviation, the mean approximately 0.68, 2 standard deviation 0.95, and 3 standard deviation 0.997. Now, it's explained here in this figure. If this is our mean value, so this distance means mean minus 1 sigma and mean plus 1 sigma. So when I think as an area, so this area is 34.13 plus 34.18, which is 68.26. So approximately to 68%. So we are not saying that 0.26, so approximately 68%. When I have mu minus 2 sigma or mu plus 2 sigma, so this total area, which is the probability, 95%. And when we talk about the mu minus 3 sigma and mu plus 3 sigma, this is 99.7. So it is easy to get a conclusion that when we talk about any kind of probability, so we are talking about the distribution of the x, distribution of the random variable x, at the end, all the data values or all the probabilities are always mu plus minus 3 sigma, which means mu minus 3 sigma, comma, mu plus 3 sigma on the left and on the right. So if mu is, for example, 100 centimeter, and if sigma is 10 centimeter, it means that 100 minus 3 times 10, 70, 100 plus 3 times 10, which is 130. So all my values are between 70 and 130 units. Now, standard normal distribution. What is standard normal distribution? We say that the standard normal distribution is a normal distribution with a mean of 0 and the standard deviation of 1. And if we call that this mu, which is 100 centimeter right now here, if I call this mu is 0, okay, when I call this mu 0 and standard deviation is 1, so this figure will be same distribution, but I will write here 0, 1, negative 1, negative 2, positive 2, and negative 3, and positive 3. And I will say it here, z score. I will say it here, z score. What does it mean? So for example, 68% of the data will be mu plus minus, not mu, since mu is 0 here. Let's say within plus minus 1 z score, and this area, which is 95% of the area, will be plus minus 2 z score, and finally plus minus 3 z score will be 99% 7. Meanwhile, what is the z score? If you remember, it is x minus mu divided by standard deviation. So x is the thing in the given question, the number which will be given in the question, and mu is the mean of the population, and this is the standard deviation of the population, and this is the z score. Somehow, if you need the x, you can say that this is equal to z times standard deviation plus mu is equal to x. So you can derive from this equation, this formula also, that is possible. Now, that's the thing, the value minus mean divided by standard deviation. So we say that between negative and positive 1, 68% approximately data occurs. So the things I can test. Now, find the area to the left of 1.99. What does it mean? When the z score is 1.99, so according to the z score, of course, there is one x value here. What will be x value right now? I don't know. Okay, it depends on the question, but there is one x value. So the thing is actually this: what is the probability of x? So if I call this x value as a, what is the probability of x is less than a? The answer of this question is this area. So this area answered the question, what is the probability of x is less than a? We will see the example. And then how can I find this? I can use the graphing calculator, or I can use this online website I just told you here. Where was it? So let's check it. It must be here. Normal. Okay, when you click the normal distribution. So for example, standard z score, put it here, 1.99. 1.99. And then when I say calculate, it says 0.977. So check it. What is the answer of this? Where is it? 0.977. It says why it rounded this. When I round this 6 over 7, 0.977. So results comes out like this. And don't forget, now you have the standard normal distribution. Mean value is always 0. Standard deviation is always 1. So we are not touching these things. We are not changing. Now, so question.
What if we are trying to find more than 1.99?
More than 1.99.
99.
Everything you can put. You can put 2. You can put
If
1.6.
I want to find how much is after 1.99.
Yeah, it's so simple. You can calculate this one, and 1 minus that z-score will be the answer of your question. But sometimes some calculators gives this option also. Some calculator says you are looking for that z-score left side, or you are looking at that z-score right side. For example, TI 84 CE plus, which I do not have this one. I have the classical one. Classical one shows just the left side, but this one shows, or the uprated model shows that it says which z part you want. You want left, you want right, or you want between two z-scores. It asks between them you want to find. But now it's not our problem. So by using a calculator or by using this Tell Me web page, we can answer our question. So your answer of your question, you said that, teacher, if I am looking for what is the probability of probability of x is greater than a, if for the a, z-score is 1.9, so greater than means right now this region. So how can I calculate this? 1 minus probability of x is less than a. So x is less than a is a z-score is 0.977. So 1 minus 0.97 will be answer of your question. Right now, do you have question?
Yes, Mr. What does A stand for?
A is a number, random variable. We will see an example now. Just wait it.
Okay.
Let us learn how to find, and the real example we will see it, inshallah. But we have 14 minutes, so let me go a little bit quickly. So okay. Same thing, z-score. It says that, as you asked me right now, find the area of the right of the z-score. I mean, if the z-score is this, find this side. What am I going to do? I will do this one. 1 minus z-score, negative 1.16. So let's come back here. Let's find negative 1.16. So when I calculate, it is equal to 0.9777. So 0.977.
Mr. There was an error.
Pardon?
There was an error inside the calculator. You must be exactly one.
But how can we calculate this then? If I say positive 1, result comes out. 1 minute. It is changing or not changing? 0.5, let me say. It's not changing, so there's problem here.
No, Mr. It's the same.
Pardon?
It's the same. It says it's the same. Oh, no.
So always comes the same thing. So it's not a good idea to use this, or there is one bug, I don't know what is that. I will use my normal calculator. I can use my normal calculator, but it says z-score, right? So standard z-score. So what is the standard z-score? Negative 1.16. So when I put negative 1.16, it should work normally. Yeah, it works right now. No, yeah. What happened? I don't know. Anyway, so negative 1.16 z-score is 0.123. So when I put it 0.123, right? So the result will be, let me use calculator. So 1 minus 0.123, which is 0.877, 0.877. So approximately, if I multiply by 100, 87.7%. So this is totally 87.7% or 0.877. Let's check it, the calculation here. Yeah, this one or 87. Come on. Now, when we talk about between these two things, what are you going to do? I think in this calculator, we can't use this. In my calculator, I can use this by using the normal CDF. But what can you do? So between them means, so calculate this Z 1.68, which means as an area, this, okay, all this left side. And then calculate the Z negative 1.37, which means only this area. So when you subtract them, the result, so it will be only this part. On the number line, if I show, this is all the Z, which is this one, and this is Z negative 1 point something here. So when I subtract from this result to this result, what will be? This is the thing what I want to see. Or in my calculator, normal CDF, second variance, normal CDF. When I say enter, lower bound is negative 1.37, negative 1.37. And then upper bound is 1.68, 1.68. Enter. So no need to change mu and the sigma since this is standard deviation. It is being negative 8682. Negative? No, 0.86 and 82 when I round it, which means 86.6% or 62%. Let's check the calculation, exactly what I said. Okay, so you can use the calculator if you have. If not, the website, calculate this result. If you wish, we can do it quickly on the website also. Let me tell you, what was it? Tell me. 1.68. So write it here, 1.68, and calculate that one.
There's a problem.
I don't know why it's being like that, 1.68.
It says restart the website. Click restart.
1.68 for calculate. Okay, refresh the page now. 0.954, 0.954, and then negative 1.37, negative 1.37. Okay, let us refresh the website. Negative 1.37 and calculate 0.085, 0.085, and then just subtract them. So 4, 5, no, 14, 5, 9, 4, 8, no, 14, 8, 6, 8. So this one, 0.869, so 0.86, look at here, 0.868. So this is 0.8869. So it's a very small mistake. It's acceptable. It's not a big issue. Okay. Or just maybe I did calculations. Let me use my calculator. Maybe I did calculation problem. 0.954 minus 0.085, which is, yeah, it is same as what I did. But when I use the calculator, this result exactly comes out. It's not a big issue. Now let's go down. Now, this is the answer of your question, how we use this. Now find the probability of for each. Probability of z-score between 0 and 2.32. What does it mean? So it is this. So you know that this is always mean, which is 0. So 2. Let's say 32, it is here. The question says that find this area. So how can you find this area? So if you have the calculator as I have, you can put it. Let me show you here. Second variant. Let me finish and later you can ask your question. 0 is the lower bound and upper bound is here 2.32. 2.32. 2.32. And no change here, no change here. Result comes out as 0.4898. So 0.4898, 0.4898, which is exactly here. So what can you do? Take the online stuff, 2.32, same thing. There is no problem. I mean, 2.32, and then calculate the, let us make it again, refreshed, 2.32, and when you calculate, it is 0.990. So 0.990. And then what about 0? When you have the 0, again, refresh the page and put it here 0, and you will see probably 0.5. Let's see, yes, 0.5. So when you put 0.5 here, 0.9954, 0.49. So when you round this 0.4898, it will be 0.49, which is acceptable, which is correct. Okay, if you use that one. What about z is greater than 1.91? So it's so simple. Find 1.91 result here, and then 1 minus z 1.91 will be answer of this part.
Yes, sir. Can you please go back up? I want to show you something. Yes. No. The last question. Yeah. We can calculate what's less than 2.32, and then we minus 50%. Yes, minus 50%. That's it. Okay. Since when you use the calculator, it calculates all this area, and we know that this is 0.50 also. So all this area minus 0.50 gives us this part. That's it. Now, so 309, what was the last page we said in quiz? Up to 319. So let me continue quickly. So this is same thing for z-score, so nothing different. Let me pass. Not important. Yeah. This question, last 2 pages, be careful. This question, I will ask similar to this one. A survey by the National Retail Federation found that the women spend on average this price. So average is, let's say, on average 146. So this is the now new 146.21. Since it says the average, which means mean, okay? Assume the standard deviation is this. So standard deviation is 29.44. Find the percentage of the women who spent less than this. So question is probability of X is less than 160. Assume that variable is normal distributed. So let me explain quickly. If you have scientific calculator, this, normal CDF, and then here the lower bound, be careful now. When you draw, not z-score, just variable. Okay, let me say the mean is 146. So the peak point is 14621. And then the thing is 160. So let's say approximately here. The question is, what is the probability that something is less than 160? So what am I going to do? So for this lower bound, you know that it goes negative infinitive. Okay, so 14, 13, 12, 10, negative 100, negative 10, whatever. So I will choose the lower bound is, as a general concept, negative 100. Always I am taking negative 100. Upper bound, this number, which is 160, 160. Now mu is 146 to 1, 146 to 1, and standard deviation 29.44, 29.44, and then result comes out 0.68025. So 0.68025. It means that 0.6803, if I round it, it means that 68% 03. So that's my answer if you have the calculator. Now, if you don't have calculator, by the way, what is the final result? 6808. So 6808. That's good. Now, what am I going to do? What am I going to do? Be careful now. That's important for you. You should calculate the z-score. What is the z-score? Here, let me explain. X minus mu divided by sigma. So X is this, which is our value. Mu is the mean, and standard deviation is this. So result comes out 0.47. What does it mean? My figure, this figure in terms of X, right now in terms of Z table, Z is right now here 0.47. 0.47. The question is find this area. And then where is 0.47? You can use this website. Come here. Let's make it refresh. 0.47, 0.47, and then calculate. 0.681, 0.681. If you multiply by 100, it will be 68.1%, which is 68.08. So this thing is a calculation problem on the website, okay? Exactly this is the answer. Or when I use my calculator, what I got, actually this is the exact answer. 68.0254, blah, 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 okay? So it's acceptable thing. It's not a big issue. Don't worry about this. That's it. We found. We calculated. Anything to ask me how did I do it? So you should find the corresponding z-score. So look at the question. Look at the question. It says 160 and less. So find the z-score of 160. Put it here, 160. 146, 29, so mu and sigma, the formula is this, and find the z-score. Now you find the z-score, so this is being 0.47, so this is the area, which is the answer of the question. And then by using the calculator or website or the table, we got this result. So what is the meaning? The woman spent less than $160 is 68%. So 68% is spending less than $160. So if the question is find the women who are spending more than $160, what will be answered? The answer is 1 minus probability of X is less than 160. Less than or equal, same thing, okay? Less than or equal, same thing. So it will be 1 minus this result, which is 0.681, and then blah, 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 it comes out. Okay, if it says greater, calculate this and subtract from 1. That's it.
Sir,
yes.
What about the table? We don't have to use the table?
If you want, use the table.
No.
These are the practical one.
Okay.
So you can use the table also.
The
Finally, you will get this result.
Yeah.
Okay. So the thing is here. Let us finish this. The thing is here. It says that the mean is 28. So I'm not reading the question. The text is here. You can have a look. But just talk about the solution. So mean value 28 given. So number 27 and 31. So what is the probability of something between them? So what am I going to do? If you have scientific calculator, you can use it. Lower bound is this. Upper bound is this. And then this is the mean. And the standard deviation here given 2. And then calculator calculates the result. But if you don't have, find the z-score of 31, which is 31 minus 28 divided by 2. This is mu, this is sigma. Calculate the z-score of 27. 27 minus mu divided by sigma. So the answer will be negative 0.5 and 1.5. Now this is in terms of normal, in terms of z-score. So you are looking for this area. So, and we'll learn how to find this area. First, you calculate z 1.5, get a number. Let's say result is A. Calculate z-score of negative 0.5. Let's say result is B. So what will be this area? It will be A minus B. So this result minus this result will be your answer. And here, the first is 0.9332. The second is 0.3085. So when we subtract, it is 0.6248. So 62.47% will be answer of the question. That's it. Okay. In terms of the z-score, or in terms of the X variable. And if the question is more than this, what are you going to do? You will find the z-score. Let's say the z-score is 1.1. So when you use the z-score 1.1, first you calculate this. After that, to find this, 1 minus z-score 1.1. That's so 1.1 z-score is being, let's say, what is that? 0.137, or what's that? No, 1.1 is 6843. So this is being, or this area is 0.6843. So what will be this area? It will be 1 minus 0.6843. That's it. That's the answer of the question. When you understand, I don't think so it will be difficult. So just understand the general concept, what I have explained right now, so you can solve all the questions. Look at, for example, here, it says that this is mu, this is a number. So find the z value, 15 minus 25 divided by sigma, this one, and then use the calculator, use the website, calculate it, which is this one. If the question is asking this area, 1 minus the result, you can say it, so it will be answer of the question. Okay, guys.